Welcome back to another video in the series, and today's topic is describe encryption and hashing. It's a pretty simple and interesting topic. So let's explore or rather describe encryption and hashing. All right, so what is encryption first? Let's start with the encryption. So encryption is the process of converting a readable text into unreadable data or cipher text. So there is something you could say. There is this text. Let's call it hello. Right? We can read it, but if we encrypt it, right? If we encrypt it, this will not become readable. It will be something like you must have seen these kind of something like this, right? So this is encryption when the plain text is no more plain text and you cannot read it. It become unreadable. How? With the help of a key. There is a key, right? For example, you must have seen, like, let's do this +1. So if it is H, whatever the next word of H, A, B, C, D, E, F, G, H, I. Similarly, E, F, F, L, K will become this. What we did, we just encrypted by +1, all these things. So this is what the encryption is in simple terms. Changing the plain text into cipher text. This is cipher. Cipher means it has been encrypted with some key, right? So I hope this is absolutely clear. That's how we describe in a very simple, easy way. Now, the point is we understood this, but there is one more thing. Types of encryptions. We have symmetric type of encryption, okay, and we have asymmetric type of encryptions. As the name says or sound, it exactly the same meaning. Symmetric means this +1 key. We are encrypting with this key, and this is we are getting this result. Okay. Now when we need to decrypt, we need to again utilize the same key +1, and we will get the result. This is symmetric encryption. We use single key to both encrypt and decrypt. So if we go this way, we are decrypting. Okay. But when we were coming this way, we were encrypting. And in both the scenario, we are using the same key. So it's that simple. If we talk about Azure, we have Azure storage, which uses SSE, storage service encryption, and this uses the same methodology, symmetric encryption. So Azure encrypts all stored data in Azure file, table, queue using symmetric key encryption with the help of AES 256 algorithm or symmetric encryption algorithm. Okay. All right. So symmetric is pretty clear to everyone, I hope. Now it's time to talk about asymmetric. Now, as the name says, asymmetric means when we are going this way, we are encrypting it, this particular piece of information, encryption. We are using this key, okay? But when we are decrypting, we are using a different key. The key will be different. So we are using two keys. It's a different key than we use for the encryption. So What are we using? We are using two keys. What are these keys? One for encryption, and second key is for decryption. That's the reason it's asymmetric. Simple, right? Now, these two keys, the concept of these two keys are clear, and that's why we call it asymmetric. Now, let's go further. The one which is used to encrypt the data, we usually call it a public key, and anyone can access it. And only people who can decrypt the data which is encrypted by this public key with the private key, which is a pair of this public key, and somebody owns it. Only that guy can decrypt it. So we have two kind of key, public key and private key. Public key will encrypt and private key will decrypt. Public key is available or accessible by everyone, but private key only accessible by the owner of it. So where we use it? We use it just for the understanding in TLS and SSL. We use it in digital certifications of signatures and Azure Key Vault encryptions. All those things uses this, right? Even when you log into the Linux. Now we can take this example a little further. When we visit any HTTPS website, our browser encrypts data using a website's public key, because public key is used for the encryption. Now, website's private key decrypts the request and process it securely. That's how it happens. We can explain it further. But for now, we understood what is encryption with the help of this simple example. Then we understand the type of encryption with the help of these two examples. Now, it's type it's time to go further. So in cybersecurity, encryption is used to protect data in different states. Ultimately, what is there on the storage account? Data. What is there on the VM? It's data. What is there in TLS tunnel that created encrypt and decryption is happening? It's data coming in, coming out, right? So it's data. Now, data needs to be encrypted, and it has three states that we need to encrypt it for, like resting data, Azure storage, transit is the TLS and SSL, and in use. This is something interesting, and we'll talk about it. So let's see how to encrypt data when it's in a resting stage. First one. So encryption for data at rest or stored data. So what is data at rest? Data stored in a storage account. It's resting. Nobody's using it. Just there. It's lying there. Refers to the information stored on a disk, a database, file, server, or in the cloud. Right. So we need to encrypt it. And if this kind of encryption is happening, symmetric one SSE, that Azure takes care by default. And you can also use your managed key, like customer managed key, if you're not happy or need to maintain any compliance, right? Now, why encryption for data at rest important? We all know that, right? We have talked about it many times. But just for sake of this video, it prevents data theft if storage devices are stolen or hacked. Most of the time, we also need to meet some kind of compliance like GDPR, HIPAA, or ISO. So that is one of the security measure you need to implement in your organization. Now, in transit, let's see in transit. Transit is when data is moving from going one place to another. This is transit, right? Like there is a web server here, and here is somebody who's trying to access that website. So it writes www.xyz.com and it will create a connection. The response will go back. So it's a in transit. Data is moving. So without encryption, data in transit can be intercepted by a hacker. So if this guy accessing web server from here, What is the risk if this is not encrypted? Somebody sitting somewhere wearing maybe a black hat, right? So what it will do, it will try to intercept data, this data in between. If it is not encrypted and if this guy is successful, then you lose your information, right? We call it man in the middle. MITM, man in the middle. These kind of attacks will fetch or get your information and your system will compromise. So we need to encrypt in transit. And this encryption ensures, if you remember CIA in the previous video, ensures confidentiality. So only the intended recipient can read the data. And of course, it prevents eavesdropping on sensitive information like password, credit card details, a lot more. We understand the importance of encryption, but here data is moving, so we need to encrypt data in transit, and both in rest and in transit has a different mechanism to encrypt it. So HTTPS is our example of data encryption for data in transit. So the server, this web server presents a digital certificate or SSL TLS certificate when you try to access something, and your browser verifies the certificate authenticity. Okay. Now, once the browser verifies this, the two systems establish a secure encrypted channel like this one, secure encrypted channel after the verification. And now the data you send, or like when you log in passwords or maybe credit card information, this data gets encrypted before transmission. So it gets encrypted because it utilizing this key, the public key of website. The data is encrypted. The encrypted data will reach here now because this website is owned by you and you are the owner of the private key as well. So you can encrypt the data only, nobody else. So if there is a credit card information, there is a PCI compliance, right? So one of the check mark will be this encryption, right? So that if anybody try to hack your password or your credit card information, it should not, because there is a secure transmission channel and data is getting encrypted before sending it. All right, so this is encryption data at transit. One of the example is the VPN one. Without a VPN, hackers on public Wi-Fi can intercept your data, right? But with VPN, data is encrypted and protected from snooping. Because if you remember when we learned the VPN gateway, that's what it does. It encrypts data before sending and decrypts data when the encrypted data comes in. Now, these two things are clear. Okay. Now, there are three states of data, right? When data is just lying around, data at rest, and then it's moving in transit. Now, in use, because uh, a website cannot use the encrypted data, needs to be decrypted so that website can understand, or SQL when website is talking to the SQL, right? So that is in use. So while data in use, how we need to protect? Maybe this guy sitting here not uh, trying anything silly on the storage account or on the transit, but it's waiting when the data will be encrypted and in use. Only then I'll do something. So we also need to protect data in use. So data in use refers to information security being processed, accessed, or modified during that time. So viewing or editing a document in a Word, so it's in use right now. Maybe your Word sitting on your disk is encrypted, but you opened it and you're doing something, so it's in use now. Or running a database query to retrieve customer records, maybe. These are some examples where data in use. Why this encryption for data in use is important? Well, it prevents data exposure in RAM, which is random access memory. If a hacker gains access to the system, it can get the data when it is in use, when the data is in RAM, because it's not encrypted. And it protects sensitive data from insider threats. So we understand that we need encryption for data in use as well. Let's take an example like Azure Confidential Computing ensures that data remains encrypted even while being processed. So what they use TEE, Trusted Execution Environment, such as Intel SGX or AMD SEV. So only authorized application can decrypt and process data inside a secure enclave. All right. So if you remember that we talked about BitLocker, right, which we use to encrypt Windows, right? BitLocker in it also gives in-memory protection. So if you open a password-protected file, the data is decrypted in memory for you to read and edit. If someone steals the RAM, cold boot attack, we call it. So we talked about data in rest, data in transit, data in use. All these three things are covered. Now, and it is good, more than good information from the syllabus perspective, describe encryption. We know a lot more about it now. Now, what is hashing? Well, we have learned password hash, right? Sync. So, for the people who are new, hashing is a one-way process that converts data into a fixed length hash value. So, there is a data, and if you apply hash, there would be a hash value. But in this case, in encryption case, we are decrypting it by the same key if it is a asymmetric or symmetric encryption. But in hash, it cannot be done. It cannot be reversed. So how does it work? You take the input data, just like this one. You take the data, okay, and you apply a hash. There is a hash, okay. Hashing algorithm like SHA-256 or MD5. There's so many, right? And there is a output. There is a output, and it would be some random number, list of random numbers. You cannot reverse it. This will become the hashing information. And even one small character, even if you apply dot or a space, one small character changes the hash value completely. So hashing is a different to encryption in the totally different to encryption in that it doesn't use keys, and the hash value is in subsequently decrypted back to the original. So in that sense, you can easily understand it. It is a different mechanism altogether. And where do we use it? Well, the system hashes the password using SHA-256 and it stored the hash value, not the password. So whenever you try to type the password, you apply the hash and it should have the same value and it will match and give you the results. So this is hashing. Simple and sweet. If we would like to see the difference between encryption and hashing, the very first thing is encryption can be reversed, but hashing cannot. It's a one-way process. And we talk about the purpose. Remember CIA? Now, if we talk about the purpose, the encryption is taking care of confidentiality. However, hashing will taking care of integrity because even a dot will change the hash, right? And if we talk about encryption, we have AES, SSE, RSA. In hash, we have algorithm like SHA 256 and MD5. Uh, yeah, that's all